Hello and welcome to the first of a series of UK NEQAS for microbiology webinars. I'm Dr. Jennifer Henderson, the scheme organiser for bacteriology and mycology, and I'm proud to introduce today's first webinar session on how to handle the EUCAST new definitions of S, I and R and the use of ATU. We've done a few preparations and practice runs of this webinar to iron out any technical hitches, but please do bear with us if this does happen. I'm sure we're all familiar by now with Zoom, but just to run through a few housekeeping rules, we're all aware of how the webinar will be formatted. Our speaker will present his slides, followed by approximately a 15 to 20-minute Q&A session with our very own expert advisor, Mandy Wootton. If you have any questions to ask, please submit them in the Q&A function, which can be found at the bottom of your screen. All questions can be viewed by attendees, so if there's a question that you would really like asking, you think is important, please feel free to upvote the question by clicking on the thumbs up icon. The more the question is upvoted, the more it's likely to be asked. We won't be using the chat function to answer any questions, and I would ask that you don't raise your virtual hands. We will be recording this webinar and sending links to the on-demand recording to all registered delegates within the next few weeks. It isn't possible for us to award CPD points as we can't verify attendance, but registration significance will be emailed out to you shortly. We would also suggest that for CPD purposes that you write a brief reflective statement on what you've learned from this session. So without further ado, I am pleased to introduce our speaker today, Professor Gunnar Kalmita. Gunnar is a leading authority in the field of antimicrobial susceptibility testing, antimicrobial resistance, and infection control, working in the front line of harmonizing international clinical breakpoints. He is both former chairman of EUCAST from 2001 to 2012 and president of ESCMID from 2012 to 2014. Gunnar is also head of the Department of Clinical Microbiology in the Swedish hospital region of Kronenberg for more than 30 years, and he is today head of the EUCAST Development Laboratory and National Reference Laboratory on Phenotypic Susceptibility Testing. So Gunnar, if you could please share your slides, and I will hand over to you for the presentation.
Hello everyone, and greetings from a very sunny Sweden today. It's a bank holiday here, which I didn't realize, but never mind that. I'm going to talk to you about how to handle the EUCAST new definitions of S, I, and R. And at the end of things, we will also discuss the area of technical uncertainty. And how did that come about? And what are you supposed to do with it? So without further ado, let's get into the presentation. In 2019-20, EUCAST changed the definitions of S, I, and R and breakpoints to match. And we did that to emphasize that phenotypic susceptibility testing is quantitative, that all breakpoints are related to a dose or an exposure, if you like, that not all sensitive organisms are equally sensitive, and that resistance mechanisms may still be overcome, but will need a higher exposure of agent than the wild type variants. This is the old definition of I, and we actually have this in common mostly with CLSI and with the previous ISO document. And it's stated a microorganism is defined as intermediate by level of antimicrobial agent activity associated with uncertain therapeutic effect. It implies that an infection due to the isolate may be appropriately treated in body sites where the drugs are physiologically concentrated or when a high dosage of drug can be used. It also indicates a buffer zone that should prevent small uncontrolled technical factors from causing major discrepancies in interpretations. So that was a bit of a mouthful. And when you look at it closely, you will discover that it consists of three rather different parts: uncertain therapeutic effect, where drugs are physiologically concentrated or when a high dosage of drug can be used, and a buffer zone to prevent small uncontrolled technical factors to cause major discrepancies. So you may ask, who is responsible? Well, uncertain therapeutic effect, that's really the responsibility of the pharmaceutical company, the clinical trials that were set up and the evaluation of these performed in EMA, dose finding studies, and eventually also EUCAST when determining breakpoints. The next part, where the drug is physiologically concentrated or when a high dosage of drug can be used, that's really the responsibility of clinical colleagues to understand how much do I need to give? How much agent do I need to give? And what agent should I use? And which agent is better than another agent? And how do I choose the appropriate dose and the mode of administration? And if I choose this dose, will it actually reach the site of infection? The third part, the technical buffer, if you like, well, that would to some extent be the responsibility of EUCAST. We would avoid setting breakpoints that cause problems. But it's also in the hands of the manufacturers of AST material and devices, and finally and foremost of the laboratory that performs the AST. So there you are, three different meanings rolled into one category represented by one letter, I. But there was no mechanism to inform users or recipients of reports as to which of the three meanings was intended. The report just said I. And an effect of this was that intermediate results were undefined, poorly understood, and generally distrusted. Intermediate results were normally lumped together with resistant results, both by laboratories, by clinical colleagues, and by surveillance programs. So it was very common for also very large and very formal and official surveillance programs to lump together R and I as non-susceptible. And as a result of this, over the many years, clinical colleagues have more or less systematically avoided using agents reported as an intermediate. So this is really the challenge in a nutshell. We now need to inform and educate users about how to utilize and take advantage of having two susceptible categories, namely S and I, rather than two resistant categories as we had before, I and R. And we need to all pull together to achieve that. And we need to reach also those that are less interested than others. So how did we end up where we now are? We had 6 different consultations, general public consultations. Any colleague, in fact, any person at all could respond to those consultations. And they were all in the period 2015 and up to 2019. You can still find all of these, both the actual consultation documents, but also the comments given by people and the responses from EUCAST. So for anyone who's really interested, you can go to the EUCAST webpage and then click on consultations, and down the list you will find all these 6 consultations that I have listed here. So there was a need for a new definition. And the new definition is I, susceptible increased exposure. And the rather long text that went with the old definition is now a microorganism is categorized as susceptible increased exposure when there is a high likelihood of therapeutic success because exposure to the agent is increased by adjusting the dosing regimen or by its concentration at the site of infection. And I've listed the old definition below just for comparison. So EUCAST decided to keep the letters S, I, and R. Why? Because we polled colleagues around the world, we polled national AST committees, we polled ESCMID and ESCMID study groups, We polled EMA and the antibiotic section in EMA. We polled ECDC. And when we put together all the responses, which were more than 100, it turned out that more than 80% were in favor of not changing the letter I. We also asked companies, manufacturers of AST material and devices, and they were also in favor of not changing, one of the reasons being that it would take forever to change package inserts and what have you not. So it was decided to stay with SI and R. It was decided to emphasize the relationship between the breakpoints for categorization and the concentration of the antimicrobial agent at the site of the infection, which we have called exposure. And I would just like to take this opportunity to remind you that there is a difference between dose and exposure. And the reason I do that is because we quite often get questions, why could you not just say increased dose instead of increased exposure? People don't understand exposure. But the dose is, of course, the amount of drug given to the patient. And it can be changed by upping the individual dose, 1 gram times 2 to 2 grams times 2, or by changing the interval between doses. So instead of 1 gram times 2, you give 1 gram times 3. Whereas exposure is the amount of drug which reaches the infecting organism. And you can change that by changing the dose, as shown above, or you can change the mode of administration. And it's today a well-known fact, for example, that for many beta-lactams, if you go from IV injection to IV infusion, and the more you prolong that infusion, you will be able to gain an MIC step or 2, depending on how you do that. And then, of course, by utilizing the quirks of pharmacokinetics of the agent, you can increase the exposure at the site of infection. So for an old agent that none of you have ever used, probably spiramycin, which is a macrolide type agent, it's actually concentrated in saliva and tonsillar tissues, and it's concentrated to the effect of being maybe 10 times as high as in serum. EUCAST also decided to review all and revise the relevant breakpoints to ascertain that breakpoints now correspond to the new definitions. And also to remove from the definition the uncertain effect. We said this is the responsibility of EMA and of the company and of EUCAST when setting breakpoints. So when you are advised as to which breakpoints to use, there should be no uncertain effect built into the system. That should have been taken care of by the company, by EMA, and by EUCAST. And also to take away the uncontrolled errors part of the old definition, and to instead task clinical laboratories with the responsibility for the uncontrolled errors. But also for EUCAST to help identify and form strategies for those difficult areas. And that's how we decided to introduce the concept of the area of technical uncertainty, which we will return to in a little while. So the category susceptible increased exposure is assigned when there is a need for higher than standard exposure, either because of an intrinsically lower sensitivity of a species to an agent. The wild type is reported I, and you will only ever receive an I or an R in the report. S is no longer possible. And here is a good example of that. With a change, Pseudomonas aeruginosa will never be S for ciprofloxacin. It will, at best, be I. And the alternative, of course, is to be reported R. Or because acquired low-level resistance has reduced the sensitivity of the organism, but it's still available for therapy, And in these cases, either of the categories S, I, or R may be possible. And strep pneumo and benzyl penicillin is a good example of that. So basically, we have two levels of susceptibility in Streptococcus pneumonia for benzyl penicillin. If there is an MIC of 0.06 or below, it's normal exposure. And if the MIC is between 0.12 and 2, that's increased exposure. And when you get to 4, forget it. You're not going to dose yourself or change exposure to help. Since all breakpoints are related to dosage, or if you like, exposure, EUCAST decided to list the minimum dosing requirements for the susceptible categories S and I. The document is not a therapy guideline. It's meant to inform the user of what dosing EUCAST considered when determining breakpoints, when performing PK/PD analysis, etc., etc. And also what the proportional difference between standard and increased exposure is. There are other factors that will influence which dose and which mode of administration you will choose. Severity of disease, where the disease is located, etc., etc. We've broken out so far a few of these, and there are specific breakpoints for meningitis, for example. We're right now reviewing endocarditis, and we have since way back specific breakpoints for lower urinary tract infections. I think the important message here is, if on a local or national level, lower doses are generally used than those listed in the EUCAST dosing tab, those breakpoints in the tab, in the breakpoint table, may not be valid. And it should certainly generate a discussion inside that country. And I know of several countries where the dosing tab has generated that sort of discussions, and where also it has generated change. This is where you find the clinical breakpoint table for bacteria, for fungi. You find the dosing table. And before someone asks about it, yes, we are now, together with the European Society for Pediatric Infections and a task force put together by EUCAST and that society, looking into how do these dosages correspond to pediatric dosages. So there will eventually be a document that sort of translates adult dosing to pediatric dosing. This is how the dosing tab looks. And just to show you that there is a column for the agent, then there is the standard dosage, the high dosage, and specific dosing for uncomplicated UTI. And then there are some special situations described in the last column, such as meningitis and dosing in meningitis. And for all of that, we have consulted, among others, the ESCMID study groups on central nervous infection diseases, or central nervous system infections, and other groups involved and specialized in these. Now, this is one of those that cause a lot of questions and problems for you. And I've broken out the Pseudomonas tabs. I've deleted those that have no breakpoints at all, but I can now see I've forgotten to delete ertapenem, but never mind that. And you can see that for several of the agents, the S breakpoint is less than or equal to 0.001 or more than 16. And you can see that 001 or 0.001 reoccur in several places. That breakpoint is an arbitrary breakpoint. It is meant to guarantee that no one ever gets an S as a result of a susceptibility test. you're not meant to get an S. EUCAST has decided that there is no situation in which a Pseudomonas, in this case, for ciprofloxacin should ever be S. It should always be increased exposure. So the two arbitrary breakpoints, or signal breakpoints, if you like, is the MIC breakpoint S less than or equal to 0.001 and S more than or equal to 50 millimeters, because you're not expected to get a zone diameter of 50 millimeter ever. That leaves, of course, some agents where, because of the dosing strategies of the companies, of EMA, and the acceptance of that, of EUCAST, you can still get an S. So for ceftazidime with avibactam, the ceftazidime component is actually given at the high exposure level of ceftazidime alone. So in this case, you can have ceftazidime I and ceftazidime avibactam S. But what it really means is that you can dose ceftazidime and ceftazidime avibactam at the same amount, and these will be equipotent. Ceftolozane tazobactam, meropenem with or without meropenem avibactam. And again, you can see that the manufacturer of meropenem avibactam choose to register the high dose of meropenem as the standard dose of meropenem avibactam. So how to introduce the new I? And I think, first of all, it's reasonable to accept that there are some areas that need special attention. And I think the most common email that we get is concerns about Pseudomonas ruginosa and everyone going to use meropenem instead of whatever else is available, piperacillin and tazobactam, for example. And the same holds true for Acinetobacter, but people don't seem to be very worried about that. And people are not really very worried about Staph aureus and ciprofloxacin either. But all of those are relevant for that discussion. And our advice is that you follow the EUCAST recommendation. You may have issues with it, and you are very welcome to vent those issues either directly with us or via your national AST committee, which in this case is in the UK is the BSAC Working Party on AST. But the recommendation is that you actually do introduce the EUCAST breakpoints and make serious efforts to explain to clinical colleagues, or if you like, the recipients of your reports. And that you report I with an explanation, susceptible increased exposure, and perhaps a longer comment to explain what that actually means. There are some suggestions on the EUCAST website of longer and shorter comments, and you can either construct your own or choose to use one of those. I have now seen more and more countries choosing a pathway which I would call an alternative stewardship approach. As people discuss the consequences of having lots of I's on Pseudomonas aeruginosa and not so many S's any longer, they say maybe we shouldn't actually report so many susceptibility categories on Pseudomonas aeruginosa. Maybe we should be a little bit more picky as to when and what we report. And I know now of several countries where colleagues have taken the decision to report everything according to the EUCAST breakpoints for serious infections, and to include meropenem and ceftazidime I and meropenem S and piperacillin tazobactam I, and with the comments as suggested above. But for less serious infections, to avoid reporting agents unless they are resistant, or unless the isolate is resistant to the agent, in which case it is probably good service to tell people offhand that this bug is actually resistant. And then maybe to add a comment, if antibiotic therapy is considered necessary, contact the laboratory to obtain further advice. So we're not saying that you shouldn't test, we're just saying that maybe in a discussion with stewardship groups, you should consider whether all Pseudomonas infections merit antibiotic treatment. So far, the I category and the new definition, and we can later discuss that further. And I'm sure there are lots of questions. But before we do that, let's dwell for a minute on the concept of technical uncertainty and the area of technical uncertainty as coined by EUCAST. What does it mean, and what am I supposed to do as a microbiologist? Some basics first. The performance of a test is a shared responsibility between the manufacturer of whatever devices or material we're using and the user. The manufacturer is responsible for calibrating the product against the reference methodology, making sure that discs actually correspond to the activity that should be in them. And they should issue directives for the use of the product, for the storing of the product, etc., etc. What we fail to do more often than not is to actually put some pressure on the manufacturer. And I'm not talking about a specific device, I'm talking about any device used in AST. What species were validated for this device? And which species were not validated? Which media were validated? And which atmospheres were validated? And perhaps more importantly, was the full concentration gradient, both for broth microdilution and gradient tests, both the lower and upper end of the concentration scale, actually validated for the relevant species. We have more and more frequently seen gradient tests that are poorly validated in an upper area of the concentration scale, whereas the lower area, the wild type area, if you like, seems to work okay. That goes for glycopeptides on enterococci, that goes for benzyl penicillin on strep pneumonia, etc., etc. And EUCAST will actually issue warnings on the EUCAST website against non-functional material. Problem here is that we don't have the resources, staff or money to sort of systematically look at all the material, which means that the responsibility is really with you guys and with the manufacturer. Also to ask the manufacturer that if a gradient test was not validated using broth microdilution as a reference, what other method was used as a reference? But when everything is said and done, the final result, the value, the S, the I, the R reported to a colleague is the responsibility of the laboratory. So it is reasonable to put the responsibility for uncertain results in the hands of the laboratory. With other tests, HIV detection test, COVID, you name it, we accept that responsibility without even thinking about it. We know it's our responsibility to make sure that what we put out is correct, that it's quality controlled, etc., etc. And we need to do exactly the same for our AST results, whether they are by disc, by device, by gradient test, or by any other method. Also to remember that the variability in MIC and disc diffusion, the random variability, the variability that anyone, irrespective of how professional and how good you are, will have to accept and expect, is that a target MIC value plus minus 1 dilution can normally be achieved within 90 to 95% of your results, if you're good, if you don't change methodology or manufacturer in between. And the same for a target zone diameter plus minus 2 millimeters. You can expect to reach that result for 90 to 95% of your results, provided you make an effort to actually follow the description of how to do it. If you have the internal quality control, if you have taught staff to read zone diameters and to read them alike, but you can then achieve a zone diameter result, which is plus minus 2 millimeter of a target. There are other people responsible, because for AST to be reproducible, irrespective if we talk about the value or the category, breakpoints must avoid splitting wild-type distributions of important target organisms. And that responsibility is with EUCAST, and we do our damnedest to try to avoid that. We've just identified some 10 situations, chloramphenicol and Staphylococcus aureus, none of them very interesting, but still 10 situations where we do split the wild type with our breakpoint. And we are now consulting to change that. And one of the maybe currently most interesting situations for this is colistin on Pseudomonas aeruginosa. The wild type ends at 4. The ECOF is 4 milligrams per liter, and the breakpoint set by EUCAST is 2, which made sense from a PK/PD point of view, but which causes lots of problems for you guys in external quality control situations and other situations. So that breakpoint is up for review and probably revision. For results to be reproducible, you need EUCAST, yes, but you also need good material, discs and agar and gradient tests and broth microplates and devices, and all of that needs to be of a good quality. And then, of course, staff need to be properly trained and informed. And you need to perform internal quality control 4 to 7 days a week, depending on opening hours. A small experiment which we have utilized many times in different laboratories and which we always recommend people to do is to identify all staff ever involved in doing disc diffusion, if that's what you do, to read 2 plates, 1 gram negative and 1 gram positive, at least different organisms, 5 discs on the plate. They shouldn't overlap. The zone should be easily identifiable, and ask them to read the zone diameters blindly and without comparing with each other. And then one of you will then collate all the results and present it to all the others. And you will find that unless you've already done this many times, you will find that people read differently. They have different opinions as to where a zone ends. After a couple of practices, they will all read to within plus minus 1 millimeter of each other. Luckily, most AST is unproblematic, but there are some issues that you need to be aware of. There are 2 papers that we recently put out. One is about the quality of antimicrobial discs from the 9 manufacturers that we managed to identify across the world. And we performed 2 evaluations in 2014 and 2017, and both of those are in that paper. And the other one is the EUCAST evaluation of 21 brands of Muir-Hinton dehydrated media for disc diffusion testing. And that paper is also available, and you can get at both of them from the EUCAST webpage. A third paper, which actually compares pre-poured, ready-made, commercially available plates from 9 different manufacturers, is about to come out. And again, it points to the need for knowing what your manufacturer, the one you have chosen, what the strengths and weaknesses are, And you will find that irrespective of how good or trustworthy your manufacturer is, he or she, it will have a weakness. And you may have to introduce in the laboratory a warning which says, you know, for aminoglycoside discs and with this manufacturer, we should expect to have zone diameters which are 2 to 3 millimeters smaller than those that are recommended by EUCAST for ATCC strains. And of course, that will influence where the breakpoints are as well. So here's an unproblematic example, cefoxitin on Staphylococcus aureus, painted in accordance with the MIC values. And you can see that all the low MIC values are to the right, and all the red MIC values, the high MIC values, are to the left. But more importantly, you can see that there is a pretty big hole in between those two populations. And that hole is which provides the robustness of the test. If instead, as I'm sure you would rather have, paint these zone diameters in accordance with the MEC-A status of these strains, you can see that those that are MEC-A positive are to the left and those that are negative are to the right. And again, there's a pretty big hole for robustness in the test. Meropenem on Enterobacterialis, 435 correlates. Many of these strains have enzymes. As you can see, they're outside the wild type ending at 27, 28 millimeters. But you can see that there is a perfectly logical relationship between the zone diameter and the MIC. Dark green to the right, dark red to the left, yellows in the middle. And you can see where EUCAST has put the breakpoints, and you can see that the test is pretty robust. Another unproblematic test is amoxicillin clavulanic acid versus Enterobacterialis. But remember, these are with the breakpoints for uncomplicated UTI. And you can see there is very little overlap. It's a pretty clean-cut test. And you can probably trust the S and I and R that you, well, in this case, only S and R that you get from this test. But sometimes a warning would be helpful when variation in the method is difficult to control, and piperacillin tazobactam in Enterobacterialis and in Pseudomonas is a good example of that. Or difficult to control variation in the interpretation when breakpoint splits a wild type. This is mostly avoided by EUCAST, but as I said, colistin in Pseudomonas aeruginosa is a good example. Or when breakpoints split important resistant populations, which is very much the case for ceftaroline and ceftobiprole in MRSAs. That breakpoint, from a robustness point of view, whether you do it by MIC or zone diameters, is a very difficult breakpoint to live up to. Ciprofloxacin in E. coli in the area 0.25, 0.5 is another one which is really difficult to achieve good reproducibility with. And then, of course, there are materials with known problems, gradient tests for several agents and species, Murhinton agar with a known problem for some agents, etc., etc. And that list could be made very long. The ATU is a warning in the laboratory. It's meant to be helpful from EUCAST to laboratories. We try to identify situations where you may have problems. It's nothing else. It's not a category. It's not something you should report to a clinical colleague. It's not something you should lose very much sleep over, but it's something you should consider for your everyday laboratory life. It doesn't interfere with your SI and R interpretation. If you want to completely ignore it and just interpret as the numbers tell you to interpret, that is fully possible. So you can decide to act or you can decide to ignore. It's not a susceptibility category. It's to alert laboratory staff where there is a predictable issue with interpretation. It's not to compensate for poor methodological skills. On the contrary, AST today require more skills than it ever did before. It's most often defined by a single MIC value, as in the case with the MIC of 4 for Pseudomonas ruginosa and colistin, or a short range of zone diameter values, as is the case for piperacillin, where nowadays there is only 1 millimeter value left, namely 19 millimeter, where there is a total overlap between 8, 16 and 32 milligrams per liter. And how the ATU is dealt with may depend on the situation, what sample, what agent, what infecting organism, and it's up to the laboratory to actually try to form an opinion. What do we want to do? Which of these ATUs are important to us? Some of them may be totally unimportant because you never test that specific combination. And for others, you have a better solution. But remember the amoxicillin clavulanic acid UTI breakpoint, which was completely uncomplicated. And you can see that there is very little overlap between those that have and those that have not, an S or an R. And exactly the same distribution, but now with a systemic breakpoint of 8. Here we go. And then you can see that there is a serious overlap between 18, 19, and 20 millimeters. 18 you can forget about because then you will have an extra R reported, a false R if you like, the green one on 18, but who cares about that one? But for 19 and 20 there is serious overlap, and you can either choose to just report them resistant or decide to do something additional to sort out whether they are in fact resistant, dark red, orange, light green, or dark green. And exactly how you can do that, we will return to. Here's another one, piperacillin, tazobactam, and Pseudomonas ruginosa. And you can see there is a serious overlap between 18 and 19 millimeters. Here, the breakpoint for S is 16, and the overlap here is between S and R, 16, 32, and maybe not 64 actually. Here is an interesting distribution which only recently came on the table, because this is Cephiderocol. This is E. coli. I have similar slides for Klebsiella and Pseudomonas, etc., but I won't bore you with those today. You can see there are 77 isolates. They've been tested backwards and forwards on different agars, etc., etc. And you can see that we have identified to the left those that are reliably resistant, dark red colors with no overlap, and with a methodology that looks absolutely robust with the disk diffusion testing. And then to the right, you have all the green colors, and all of those are supposedly susceptible, and there is very little overlap or no overlap inside that distribution. And then you have that area of 5 millimeters, 18 to 22, where you have sizable overlap, and most people would say, well, let's perform an MIC, and the MIC is always right. But in this particular case, I'm not so sure that the MIC is always right. But I think we can agree that for anything that ends up in the middle there, you have to do something if you want to try to sort that out. And you can either perform an MIC test, you can avoid reporting anything if you can, or you can send the strain to a reference laboratory and ask for help. So the current ATUs are with Enterobacterialis for those 3 agents, and for Cephiderocol, Pseudomonas aeruginosa, those 2 agents, and Cephiderocol, and Staphylococcus aureus for ceftaroline and ceftobiprole, but I don't think you do susceptibility tests on those very often. Staph epidermidis. If you're on a certain agar, then you may have to distrust some values around 25, 26 millimeters, if I remember correctly. And then H influenza with PBP3 mutations, they are always a bother. And the only way to sort those out is to perform an MIC. So this is just to show you the columns, the ATU column, and you can see that you can have an MIC, or you can have an MIC plus zones, or you can have just a zone diameter ATU. Basically, the ATU corresponds to the gray zone in many other tests that we perform in our laboratories. And we all have had to develop strategies for how to deal with gray zones in rubella immunity tests, or HIV or hepatitis tests, etc., etc. You can have a list of ATUs at the lab bench. There are not that many, so it's those that are relevant to you are not too difficult to keep track of. You can include a warning in the semi-automated device output if you're lucky. Maybe your LIS will allow you to include if-then sentences. And you could say if Staphylococcus aureus and ceftobiprole and a zone diameter of whatever, 28 millimeters, then give me a heads up and ask me to perform an MIC or some such thing. So what are the alternative actions? Repeat the test, but that's only valid if there is an obvious and identifiable reason for the failure. Wrong disc, insufficient inoculum, or whatever. You can confirm the result using an alternative test, an MIC, or in the case of staphylococci, a PCR for MEC-A or whatever, or a PBP agglutination. And when you do, always repeat the original test in parallel with the new test. You will definitely learn something if you do that. You can report as tested or leave blank, but add a comment to explain the uncertainty and to tell your colleague what would be needed to sort it out. And he or she may well come back and say, forget it, I've got something else going. You can play it safe and downgrade the results from I to R if you have no time to investigate. And at times it would be good to actually phone up your clinical colleague and explain and discuss what this might lead to. And if it's a recurring problem, always report it to your national AST committee, and they will then take it up with EUCAST. And it may well be a breakpoint problem, and it may well be something EUCAST can deal with. And that is the reason why we dealt with piperacillin and tazobactam and enterobacterales, and also why we're now discussing ciprofloxacin and enterobacterales. The fact that we end up in the ATU on a number of occasions is a signal that we may have to do something breakpoint-wise. Try to solve the problem if it's easy to solve. That goes without saying. If you're requested to solve the problem, if there are only very few alternative antibiotics available for therapy, then it becomes very important, of course, to get a category, SIR category, a correct SIR category into the report. In a serious infections, you want to make more of an effort than in maybe a urinary tract infection. And if it's a frequently recurring problem, as I said, you really would like to find a solution for how to act and how to solve the problem. So thank you very much. I am Gunnar Carlmeter. I am with EUCAST. I'm also with the BSAC Working Party on AST. And I'm sure there are questions. So thank you very much.
Thank you, Gunnar, for that very detailed and interesting presentation. I hope that everybody enjoyed it as much as I did. I'm now going to hand over to Mandy for the Q&A session. So Mandy is currently a consultant scientist and operational manager at the Specialist Antimicrobial Chemotherapy Unit, PHE Wales. And she also currently provides our expert comments for our antimicrobial susceptibility scheme. So over to you, Mandy.
Thanks, Jen. Just to correct you, we're at Public Health Wales and not Public Health England Wales. I won't be offended. I'm not Welsh. That's fine. So thank you, Gunnar. This is a really good talk you did there and covered lots and lots of things. But we're still going to ask you some questions. So we've had quite a few questions in, and we've had quite a few thumbs up for certain ones. I'm going to try and mix in some questions that I've had from previous, from people not on the webinar, which I think are quite pertinent. But we'll start off with the one which has had the most thumbs up. And that is expressing surprise that we kept the letter I for the increased exposure. From a clinical point of view, it's probably going to have quite a big impact. And I think people get into a habit of just seeing I as, well, it's intermediate and I'm not going to use it. So were there any reasons why I was kept?
Yeah, there were a number of reasons, Mandy and everyone else. And it was also our biggest conundrum, you can say. And it was also one of those questions that I wouldn't say split the committee down the middle, because that wasn't the case, but there were at least one or two in the committee who would have preferred for us to change the letter. But when we, as I said, polled a variety of institutions and agencies and colleagues and companies, in production of various materials for AST, but also people providing LIS systems, and not only LIS systems, but other computer systems involved, because quite frequently you have a device, and the device has a software, and then you have a laboratory information system, and that is a software, and then that system will move whatever results you have in a abbreviated form or other to the hospital information system. So you have three different systems more often than not involved. And when we then started to ask people involved in updating, upholding, reprogramming, blah, 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 whatever, all of these different softwares, it became very clear that we would be looking at probably at least 5 years and probably a 10-year period of utter confusion, where some people would be on I and some people would be on whatever other letter we choose. And we decided that when in between two evils, and we had to choose one, staying with the I, which was also the advice we got from 83%, if I remember correctly, of everyone we asked, the decision to stay with the I as a letter for increased exposure was taken. And I'm sure we'll never know exactly what would have been the right way to go. And I still have people who say, it was right to stay with the I. It would have been total bedlam, and it would have created havoc if you had changed from I to something else. And then others who say this would have been successful had you only changed that letter to another letter. So in between a rock and a hard place.
Yeah, I don't think there is the right way, is there? There isn't a good answer to this, really. I can remember the discussions, and I think I was one of the people who wanted to keep it as I, but ask me next week and I probably would say, oh no, we need to change it. It is actually quite a difficult thing to do, but I appreciate that people, it's, in a world when in our world where there's a lot of there's a lot of information coming to and fro between people, and there's a lot of things to take into consideration day-to-day work. It's quite difficult to get these quite complex issues over to people in a really good way. And that's a segue to one of the other questions, really, is there a good resource with a simple summary which can be used to help prescribers understand what the new I category means, or even what ATU means? So is there any resources that people can use to inform their users?
Well, I think the best resources we have, apart from a number of documents that explain it on the website, the EUCAST website, are the fact that we have thrown a number of seminars, online seminars, all of them recorded, where discussions on the new I and the ATU over the last maybe 2 years, quite a few during the autumn of 2020. And all of those are available on the EUCAST website for anyone. You don't have to log on or anything. They are freely available on the website. And also the consultations are quite informative. But when I look back and when I consult my EUCAST colleagues in different countries, such as, Croatia and Slovenia and Italy and Spain and Germany, etc., some of them come back and they say, actually, we haven't had any problems with this transition. We managed to explain to our clinical colleagues exactly, what it means. And they said, oh, that's surprising, but it's actually logical. But the big thing and the really important thing that transpires from all of them is that the ones that succeeded put lots of effort into explaining to clinical colleagues what it was all about. So, it will take an effort, whichever way you do it, you will have to sort of gobble it up and then put lots of effort into explaining it to your clinical colleagues who are not quite so interested in this as you may be and as EUCAST people may be.
Yeah, I totally agree. And just keeping with the different I category, you said in your talk that we're now going to, for surveillance purposes, we're now going to lump in S with I rather than, as we did before, I with R. And that will clearly have an impact upon national and local resistance rates, won't it? I don't know if you've got any advice to people who are more on that side of the equation, where they are compiling things like resistance rates and in making policy changes in view of those.
I think we've said very clearly that, in fact, you should stop lumping anything. And the best way forward is to report S, I, and R as separate items. If you feel you absolutely have to lump something together in a talk for a clinical colleague down the road or whatever, then lump S and I, not I and R. The only thing which is absolutely prohibited for the future is to lump, as in the old days, I and R. So priority-wise, don't lump, report S, I, and R separately. If you have to lump S and I and report R separately. And ECDC and EMA and other agencies have accepted that this has to be how we deal with it. Also WHO.
Thanks, Gunnar. So the next question, well, two questions, they're both very similar. Why do you give a variety of options for dealing with ATUs? Seeing as we have lots of accreditation and lots of standards now to try and make our reporting consistent, this variety of way of approaching an ATU may not make it as consistent as we'd like. So why did we go with that route?
Yeah, I realize that, not having an absolute consistent way of dealing with every ATU is creating a bit of confusion with colleagues in different labs. But I think if you think about it, you will realize that different ATUs are actually different. And they are they spring from different issues. And let me take just one example. If you have gentamicin zone diameters for the E. coli 80cc strain, blah, 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 and you're on a medium from manufacturer X, and your zone diameters are always 2 millimeters too big or too small or whatever, you can't deal with that ATU in the same way as you would suggest to deal with, let's say, the ciprofloxacin ATU in Enterobacterialis. In the first case, you would say, well, you have to up your zones by 2 millimeters, and you'll be all right. It's a systematic error or a systematic occurrence, and systematic occurrences can be dealt with by systematic corrections. The other is caused by a natural random variation in an area where EUCAST was stupid enough to put a breakpoint, which causes havoc. So there, the actual remedy for the ATU is to say to EUCAST, look, guys, you need to fix this because the breakpoint is in a stupid place. Or we could have said, you need to, let's be done with it, and let's just say that all ATUs are reported as R. That then all confusion would stop. But at the same time, we would have changed the breakpoint, wouldn't we? And for a patient who is in a fix and has very little to choose between, there is a difference between a straight R because of an MIC of 64 for piperacillin tazobactam, and a report with an R because someone couldn't be bothered to try to find out whether it was actually 8 or 16.
You're just reducing those options, aren't you?
Yeah.
Treatment. Yeah. Do we have time for another question, Jen?
I'm afraid we don't. We're out of time now.
Sorry.
It's okay. So I just want to say many thanks to our speaker today, Gunnar, and Mandy for doing the Q&A round, and everyone at UK NEQAS for making this series of webinars possible. In particular, thanks goes to Belinda Stubbs and Jen Christie, and thank you for everyone for taking the time out to join us today. I hope you found this session both beneficial and enjoyable. So this is the first in a series of 6 webinars that we'll be putting on in the upcoming months. You should see on the screen shortly the next webinars that will be coming, if you haven't already seen them already on our website. And then finally, once we've closed this session, please take a few moments to respond to the short feedback survey. Thank you once again. I hope you're able to join us for the next webinar on Thursday, 27th of May. And until then, stay safe.